In order to solve a system of equations with three variables, that looks like this, you need to get it to look like row-echelon form. To remind you, row-echelon form looks like a stair pattern on the system. Just a quick example here. The first equation would have three variables. The second equation would only have the two variables, y and z. And the last equation would just have the one variable equal to a single number. Right now, for number 4, we don't have that. All three equations have all three variables. So we're going to have to eliminate some variables in terms. We're going to have to eliminate 2x, x, and y. We get rid of those three terms, we're going to have our stair pattern that we desire, because at the end, it's very easy to use bag substitution to plug in z to the second equation, and then z and y into the first equation. So the first step is we can multiply this top equation by -2 and add it to equation number 2. The reason we do this is because -2 times x added to 2x will cancel out the 0. The equation that you multiply the constant by remains unchanged. So this top equation, even though we multiplied it by -2 just now, it remains the same. What changes is the equation that we added to. So -2 times x is -2x. -2x plus 2x is 0. So we don't see that anymore. -2 times 2y is -4y, plus the negative y is -5y. Finally, -2 times z is -2z plus 3z, that's just a positive 1z. And -2 times 6 is -12, plus the -2 is -14. The last equation, number 3, remains unchanged. So one of the three terms that we wanted to get rid of is now gone. It's created into a 0. The next thing we can do is get rid of that x from the third equation. So we can multiply the top equation by -1, and add it to equation number 3. Remember that top equation remains unchanged. So x plus 2y plus z equals 6. The middle equation we're not doing anything with right now, so that remains unchanged as well. And the bottom equation, -1 times x is -x plus x is 0, so that guy is now gone, term. -1 times 2y is -2y, plus y is going to be -y. Then -1 times z is -z, plus -2z is -3z. -1 times 6 is -6, plus 0 is -6. So two of the three terms that we wanted to get rid of are now gone. They turned into 0. And now we have two equations, the second and third, that only have two variables. And we can use them together to create an equation with only one variable. So the next thing we want to cancel out is one of the y terms. You have a multiple set of options here. You can multiply the second equation by -1/5 and then add to the third equation. I'm going to show you a way where we can switch around the second and third equation. One of the row operations is that you're allowed to interchange two rows. Now you might be asking yourself why we did this. The reason is, if I want to cancel out the y terms, this first y term, one of my terms is -5y and one of them is -y. Multiplying by -1/5 is an option, but it does involve fractions, and for those of us who aren't good at adding or subtracting fractions, it could be a less likely way of getting the correct answer. You could also do it this way and switch the two rows around and multiply the second equation by -5. and added to equation 3. Now the reason we switched it around is because we wanted to multiply the second equation by a number so that second equation remains unchanged. Because in the second equation we still want a y term. So, up here, the first equation remains unchanged. The second equation remains unchanged. The third equation, however, you're going to have negative 5 times negative y, which is positive 5y, so the y terms cancel out. So this guy right here is now 0. You're going to have negative 5 times negative 3z will be positive 15z, plus z is going to be 16z. So your third equation is going to be 16z equals negative 5 times negative 6 is positive 30, and 30 minus 14 is 16. So now you have three equations, one with 3 variables, one with 2 variables, and one with 1 variable. And that looks like the stair pattern in row echelon form in the blue writing there. From here, use back substitution. First, you need to solve for z. Divide both sides by 16, and z will equal 1. That's one of the 3 variables. Take z and plug it back into the second equation. Negative y minus 3 times 1 equals negative 6. Solve for y. Negative 1 minus 3 equals negative 6. Add 3 to both sides. Negative y equals negative 3. Then finally divide both sides by negative 1. Y should equal 3. Finally, use your top equation with all three variables, x, y, and z, and plug in y and z. X plus 2 times 3 plus z, which is 1, equals 6. So x is going to be equal to, x plus 2 times 3 is going to be equal to 6. So it's going to be x plus 6 plus 1 equals 6. Add like terms, x plus 7 equals 6. Subtract 7, x will equal negative 1. So your solution to the system of 3 equations is going to be negative 1, comma 3, comma 1. If you are not confident that your answer is correct, take this solution for x, y, and z and plug them into all 3 equations to see if it works for all 3 equations. So you can check this answer before you turn in your test.